let's take a look at when to use an optional. This is just one of the ways, there will be many more. Let's dive in. I have a person. Person is a class. It has an address class. In this case it's being set with null, and address has a street or a house number that we can get. In a more traditional way with Java, the imperative way, we describe how we are going to do this. So we supply every null check in here. We have to check if it's null, if null, if null, and then we can get the street. Since Java 8, we can do things more functional, and we can more focus on what we want to do instead of how we want to do it. So the details of how, with all the null checks, that's being moved over to the optional API. So optionals handle all the null risks for us, so we don't have to bother about it, and we can just say what we want to do, and it will be safely managed for us. So in this case, I say I want a optional of a nullable value. So in this case, I assume that person could have been null. In this case, it's not, but it could have been. And from there on, I create an optional. And so I will end up with an optional of type person. And I can map from an optional of type person to an optional of address. And here again, I map from address to an optional of string. And with the get method, I can unwrap the optional and get the string that's inside of it and assign that to my variable, or give it an else situation if the optional is empty, and it will be empty if person is null, or the get address returns a null, or the get street returns a null. Then if one of those returns null or is null, then the optional that I'm working with will be an optional of empty. So it's a status empty. Because it's an optional of empty, it will everything here will work fine. There will be no null pointer exceptions, as the optionals itself is present and not null, so the map can be called. But in the end, I will check if the optional is being filled with a value or if it's empty. If it's empty, then I can give the supplier. This is a supplier function that supplies me with a string value of, in this case, unknown. So if all this works fine without any nulls, then I get the string that's being returned by this method. Otherwise, I will get the unknown. So in the end, it will do exactly the same as this code, except I don't have to check for nulls over at every line. If the nesting goes on deeper than those levels over here, 1 and 2, so let's say 3, 4, 5, then this code will grow quite large. Over here you'll see that I have the get address method being called 3 times, the get street twice. For every additional method that's being called, this will grow as well. Then it will be recommended to have variables in between, so you don't have to call the method a lot of times, so you can store the value and can continue from there. Over here with optional, you don't have any of that. It's just you just say what you want to do. So I want to create an optional of person. Then I want to get the address. I want to get the street. If those values are empty for whatever reason, I will supply it with another value. There are more methods that you can check out. You can also throw exceptions. You can also handle this in different ways. There are lots of methods. You can also add filters in between here. So everything, probably everything that you do with an if-else construction, you can do with methods on the optional as well, but without having to check for null every time. So this is a really handy way. There are other languages solve this in different ways, like with TypeScript they have the question mark, Kotlin has something similar to that. Here in Java we have the optional, and with nested structures like we shown before. This is one of the ways an optional can help you out. So it's I really recommend learning optionals. It's a really powerful tool in your tool belt. This code will be available on my GitHub. I will link it down in the description below. Check it out.